Hi, my name is Joshua Coleman, and today we will be talking about the importance of penetration testing, and I will be challenging all the hacking skills that I've learned in my penetration testing class.
Let's get started. To perform my penetration testing on the Metasploitable VM, I plan on using network scanning tools like Nikto, Nmap, and OWASP to conduct recon and gather data on possible vulnerabilities. I will use the exploit database and CVE to uncover more about the vulnerabilities found, and use Searchplate and MSF console to implement those vulnerabilities. I believe penetration testing is important for all organizations of every level because it provides data about the organization that cannot be discovered or acquired in any other way. It shows how vulnerable or robust an organization's network defense mechanisms are against potential cyber threat actors and cyber attacks. Discovering what needs to be fixed and patched to better secure assets, resources, staff and organization personal data, and other data is imperative for a successful organization and to maintain healthy business and personal relationships. With success comes failure, and penetration testing has no shortage of failures. In the case of failure in my pen testing, I would take everything with a grain of salt. Any failure can lead to success so long as I keep trying. Taking notes of previous errors and consistently working to patch the issue, I welcome failures with open arms. They provide details about current staff skill sets and can lead to increased performance following the fix of a difficult challenge. I did a deep scan using commands for services, versions, and ports. I wanted to check out all the ports in use, including the uncommon ports, because there may be real-time scenarios where normal functions have been assigned to these ports to throw off a scan. I did not find anything of interest, but we did get some data about the open ports, the services that are being run like FTP, RPC bind, and NetBIOS, switch SSN, and the versions of these services. I am biased towards searching Apache-related data, seeing as they are typically out of date. Something interesting I found was the detail at the bottom regarding a file that contains the credentials. Right. Where is it at? Right here. I completely missed this due to my fixation on PHP, but also the amount of data pertaining to my PHP in the second screenshot. I was certain I would find something more profound than just Apache moving forward. With Nikto, I ran a host scan on the IP, and I wanted to acquire as much data as possible and compare it to the Nmap scan. Nikto provided details on the missing anti-click jacking, X-frame, content headers, modification negotiation, which allows brute forcing on file names, and most importantly, my bias standing firm because Apache is out of date. Using the OWASP tool, I ran an auto attack against the IP on different occasions and found a good amount of data. The two alerts that caught my attention were those of high alert, hash disclosures, and path traversals. I had no clue what this meant, so I did some digging, and this is what I discovered. Hash disclosures are security measures implemented to protect credentials and resources from being leaked by the web server or the database. And path traversals are vulnerabilities that enable attackers to read and modify files like credentials, application codes, or operating system data on a server and access directories. Using data from the Nessus scan, I chose 3 different level vulnerabilities, 1 critical, 1 high, and 2 mediums. These screenshots highlight the vulnerability being outdated PHP. For all 4 vulnerabilities, I hypothesized that if a system operates using unpatched software, then the system will become vulnerable to attack vectors such as port encryption, SQL injections, and application-specific DOS attacks. Each vulnerability can be identified using scanning tools such as Nikto and Nmap, and these techniques listed below. Pen testing, which is manual scanning and analysis of systems to uncover vulnerabilities, risk assessments, which are executed by identifying threats and prioritizing their risk levels based on frequency and impact on an organization, security audits, which analyze security defense data for an organization conducted to ensure compliance and omit disregarded or undetected security issues, and ethical hacking, which is a technique that demands hackers test a system before it gets the green light for operations, thereby challenging the system and hackers to discover and exploit vulnerabilities via ports, network, and vulnerability scans before the official launch. Being able to identify what tools and techniques is very useful because it helps establish what other actions need to be taken to secure a network. For secure architecture, it is imperative and necessary that there are network segmentations, which is the disassembling of a network into smaller subnets to assess how a network functions and identify any lateral movement across the network. Access controls, which process access controls, which is the process of granting privileges to users or programs for data collection or use and to approve or deny facility access, and endpoint protection, which ensures network-level security is implemented using intrusion detection, IDS, and prevention systems, IPS, that detect and respond to threats before an attack can reach the targeted device. Data encryption, which masks sensitive data from being easily readable, regardless of status, from leaks, interceptions, and eavesdropping. Threat monitoring, which is real-time monitoring of threat actors and cyber attacks. Running both IDS and IPS systems along with other security resources is crucial for this step to maintain threat detection and incident response times. Governance and compliance, which is a method of ensuring compliance within an organization and maintaining visibility and control over policies, regulatory requirements, and reports. In my data analysis, I do not believe I saw any PHP-related activity mentioned using Nmap, and there was very little data using OWASP. Vulnerabilities are to be worked on and successfully patched within 90 days because they cannot be disclosed until they are fully patched. This is particularly done to mitigate cause for concern and to keep the damage to a minimum while the patches are being fixed. There are exceptions depending on the circumstance, but it still needs to be approved by the U.S. Department of Commerce. The ability to discover vulnerabilities and implement tactics to mitigate them leads to this next step of recon, uncovering the root of the vulnerability. This is referred to as root cause analysis, or RCA. This can be achieved by implementing different methods like scatterplot diagrams, which are two-dimensional graphs that studies the relationship of numerical data via positive, negative, and no correlation correlations. This enables the development of hypothetical causes, detailing how great of an impact a problem has, and deciding which problem to solve first. Failure mode and effects analysis, or FMEA. Exploration of defects and failures during process and product design phases. This is used to foresee what is most likely to fail and to determine the significance of impact due to failed processes. And lastly, fault tree analysis, or FTA. This is a tool used to explore the causes of system-level failures. It prioritizes the highest risks as a means to resolve them first. It uses a top-down approach to identify the basic events that cause the top events to occur. I used my BCP organization to calculate these numbers. I wanted to do separate calculations for each of them, but after some time I concluded they would not yield much difference, as there isn't much data available for more day-to-day operations. The data I found occurred between the years of 2000 and 2024. That's a huge gap for the small amount of data that exists. So I calculated for the AV to be 124,000, the EF at 50%, the SLE at 62,000, the ARO also at 50%, and the overall ALE to be 31,000. Now, based on the numbers and what I believe is likely to happen, I made sure to include that in my assessment matrix. Cyber attacks happen on a daily basis, even in my industry. But according to Surveyor Hiscox, more than 50% of media and entertainment organizations experienced a minimum of 3 cyber attacks within a year. This means it occurred 25% of the time for some organizations, supporting my risk assessment matrix data, with the highest possibility being medium and possible. Now, I believe this to be the case because even though the surveyor has recorded at least 3 cyber attacks within a year, that's very minimal in the grand scheme of things because the attacks that occurred compared to the amount of cyber attacks that happen more on a daily basis, I don't believe this to be significant. Even more so because there wasn't a lot of data that discloses what these kinds of attacks were and to what companies they were affecting. Based on the information gathered and the techniques that I plan on implementing, I expect the system vulnerability alerts to decrease from 23 to 10 on OWASP for the critical issues to be resolved due to patched PHP on Nessus, and for the remaining scanning tools, Nikto and Nmap, to agree the system is in a healthier state. For my critical and high PHP vulnerabilities, it is recommended to update the PHP to at least version 4.4.5. I would do this by running these commands, php switch v to discover the version, sudo add apt repository, ppa andre j php, and then finally sudo apt install php plus the version. To resolve the HTTP trace and track vulnerability, it is recommended to disable the HTTP method trace and track. I will run the command sudo nano etc apache2 apache2.conf, add the command trace enable off and either manually restart my system or logically use the command sudo system control restart Apache 2. To resolve the clickjacking vulnerability, I must return Xframe options or content security policy HTTP header with the page's response. I'd run the command sudo a2nmod headers and restart my system. I will open a text editor and edit the text file with sudo vi etc apache 2 sites enabled 000 switch default.conf. Locate the host or directory and add the line same origin or deny. Give it permission to or to completely reject it. Then I would save the file, restart my system, and verify that the configuration has been implemented successfully. I believe these strategies will increase the sturdiness and robustness of the system. This should omit many of its current vulnerabilities and make it much more difficult for threat actors to find a vulnerability to exploit it. Strategies and their implementation reflect the due diligence and care an individual or team has exercised in fixing system issues. They are important for analyzing a system's vulnerabilities, assessing the needs and goals of an organization, determining the root causes, deciding what takes priority, creating a strategy to fix the issues, and then implementing those fixes to see the result. This ought to mitigate and harden the system thoroughly, even if it takes a few cycles to get it done right. I tried multiple vulnerabilities before I found the one that worked. I tried exploits for authentication bypass, memory leaks, and remote code, which is the one that I settled on for exploiting. I gained access to Metasploitable and tried everything that I could think of and everything that I saw in videos. I tried updating the system, updating just the PHP software, and searching through the user's bin for passwords and usernames in case I could escalate my privileges. I started with the HTTP vulnerability to address the outdated PHP and to resolve the information presented on the phpinfo.php page. Metasploitable yielded no productivity for patching the HTTP exploit. I was unable to find any usable information that either I could make out or that I could dissect in order to gain a better understanding. I found the credentials in etc shadow, but was unsuccessful in escalating my privileges. That action is currently beyond my comprehension, so I recognized I would not be able to make any progress in this after spending 8 hours during research. That's a lot longer than I anticipated to spend, but I wanted to try all that I could before moving on. I then attempted to get the files again using a different command via the Metasploitable VM, but that ended just as terribly as in the Linux kernel. Even after getting root access to the Meta VM using sudo su, nothing changed. I had hoped I could execute more commands, but ran into error after error, because Metasploit has no access to new updates or patches regardless of the interface, which is another failure in trying to patch the HTTP vulnerability. I decided to add my own credentials to the user group in hopes it would give me access to something different than root, but that also ended in failure. So I ended up moving on to another vulnerability. I tried exploiting Samba to see if I can get root access. I was able to get root access via Samba in the Linux terminal. I then tried editing the script in the editor. I failed to properly edit that text file. I tried writing it both in Linux and in the Meta VM, but they yielded the same result in the editor. I was unable to do as such. It came up with these funky characters that I just couldn't seem to get past. And every time that I tried to continue editing, it would just keep adding letters, and eventually I wasn't even able to exit out of it. So I had to restart my system every time that I tried to do an edit, regardless of if it was in the Linux terminal or in the Meta VM itself. For the last one, I tried to patch the final vulnerability for HTTP trace, but I failed to properly set up the file due to trace either not being defined or it being misspelled. I didn't know what this meant, so I couldn't necessarily figure out what it was, and even though it said that it was misspelled and defined, I thought if I was able to open it up in a text editor, maybe I could erase it or change it because it says that the syntax error is on line 51. But then I thought back to my other attempts with the other vulnerabilities, and I did not want to get stuck in the text editor once again and not be able to do anything because it took forever to figure out how to get out of it. So I chose to implement these changes because I thought it would fix the vulnerabilities and harden the system, but what I learned was much more than I anticipated. I spent countless days watching YouTube videos, reading articles, combing through anything that I can find in community threads and whatever else I could find, and basically nothing worked. I ran into issues at every step of the way. Even small things I thought would be easy to accomplish, like editing a text file in Metasploit, turned out to be just as difficult as implementing an exploit in and of itself. Getting root access was much easier than trying to write the text file. Metasploit, at least on my machine, prevented me from doing everything that I thought I would be able to do. I could only read the data because writing was a huge failure. I tried writing in my Linux terminal as well, and it ended up just the same. And what I found out after the fact was Metasploit was giving me these weird characters because it did not recognize the root terminal that I was in as a true terminal. After running my penetration test, I believe I concluded two different things. Number one, I don't think the meta VM is meant to be patched. Based on the commands that I ran, the responses that it gave me, what I was able to find in the Reddit and GitHub communities, and the guides that I followed, and other tips given, nothing changed. And two, even though I obtained a ton of information, a ton of data, I found out there are viable and secure solutions to these kind of vulnerabilities, and that there are multiple methods to implement them. Kind of like what Dr. K said in the course videos, there's multiple ways to attack a machine. The same is true for defending it. They just don't seem to work on the meta VM.